But let's confirm that our MPF policy as configured applies only for traffic between VLAN 33 and VLAN 91. Let's initiate now a session from PCB to ICE, which this should match the globally configured timeouts. The globally configured timeouts. So let's go on PCB and initiate a session to Cisco ICE 172 HTTPS 172.16.100. I think I had a typo. Instead of colon, I said a period. HTTPS colon 172.16.100. There we go. If you look in the connection table of the ASA now, we have a session from multiple sessions, but let's look at any of them. A session from PCA to server A, which currently is idle for 5 seconds, but it's going to be removed from the connection table if it's going to be idle for 1 hour. So this is confirmation that this session is going to match on the default timeouts, globally configured ones, not on the ones via MPF, because my MPF policy does not apply for this traffic type. Now let's go back on the in here. Let's go on the ASA and do this also via ASDM. So let's see how you do this via ASDM. If you go on server A and we refresh the configuration of the ASA, let's say refresh. We go under configuration, firewall, and we should go under service policy rules. And there we go. We have this global policy which has multiple class maps attached. As expected, it has the inspection default. It has the one for NetFlow, the one for ICMP, and the one for advanced TCP inspections. So we can click on any of it. Let's click on this one with advanced TCP inspections. Right click and we say edit. And on the rule actions, on the connection settings table, we can of course go in here and do a lot of other configurations. We can change the maximum total number of connections, like total number of TCP UDP connections, total number of embryonic connections, total number of per host connections, total number of per host embryonic connections. There's no default in there, but we can go and configure something. The ASA by default performs sequence number randomization to increase the security. And this is the default embryonic timeout and the default half-closed timeout. It says default. I'm not using the default connection timeout. I'm using what I've configured, which is 30 seconds. And of course, we can, if you want, we can re-enable DCD by saying dead connection detection again. Let's do that. And I'm going to retry, let's say, not 5 times, I'm going to retry, let's say 3 times is good enough. And between each retry, so I'm going to resend the DCD packets. We cannot change that each, not 15 seconds, but let's say each 0, 0, 3 seconds. TCP connection timeout value must be valid range is 0. It complains that the connection timeout is not a valid range. Let's say 0, 0. Yeah, so of course the ASA complains in the SDM that it cannot configure this very low connection timeout. It doesn't let you do this from the GUI, from the CLI it lets you do it, but from the GUI it doesn't. So let's put this to be like as we did before, like let's put it 4 hours. So let's put 4:00:00. Hour, minutes, seconds. So there we go. Okay, and apply. Now if you look at the configuration, show run policy map, we have configured the connection idle time to be 4 hours, and we configured DCD that I'm going to send DCD packets 3 times in case I don't receive an answer from the first packet, and between each packet I'm going to wait 3 seconds now. Of course you can verify that with show service policy as well. Then now for traffic matching that class map, which is between the inside network and the test server A network, the idle timeout DCD enabled and configured as expected. Now let's go to TTL documentation. So for example, if we trace route from PCB, if we trace route router 3, we're not going to see ASA 3 in the path, because ASA by default does not do TTL documentation, which means I'm not going to be able to see the ASA in the path. Of course, now for trace route to work, we have to remember that if we send packets from the PC, for example, so trace route from PC systems, it is based on ICMP traffic. So I'm going to send outbound ICMP packets and expect inbound ICMP packets. If trace route is going to be issued from a Linux system, like if this was a Linux system or an iOS device like a router, I'm going to send UDP packets outbound, and inbound I'm going to receive ICMP packets. So our trace route works is, I'm going to send, let's say if this was a Linux box, I'm going to send a UDP packet onto the destination on a high UDP port number, like 30,000 plus, with a TTL of 1. When the first device receives that packet, it's going to realize that it cannot route the packet because it has is going to route the packet with a TTL of 0, and that's not possible. So if this was the regular router, not the ASA, it would send back a TTL timer expired in transit. And from this ICMP packet, I'm going to see ASA as the first hop in the transit path. Then PCB is going to send the next UDP packet on the same high port number, like 30,000 plus, with a TTL of 2, of course, to the destination where I'm trace routing. Which means now the ASA is going to route the packet further, and the packet reaches router 3 with a TTL of 1. If ASA would do TTL decrementation, let's assume, which it doesn't do by default. And when router 3 receives the packet with TTL of 1, let's assume that the trace route was destined to router 3. So it's a packet destined to router 3, but it's a UDP packet destined to router 3 on a port that router 3 doesn't listen to, which means 3 is going to send back to PCB a ICMP port unreachable, saying I'm not listening, I'm not offering any services on that UDP port number. So to keep it simple, of course it can be more complex than this. How traceroute works is that I send outbound UDP or ICMP packets, let's take the Linux option, which was also what the iOS devices are performing. UDP packets to the destination, and each transit device, let's say I'm gonna trace route to router 4. I want to see what is the path to router 4. What are the transit devices to router 4 between PCB and router 4? Each transit device is gonna send back to me a ICMP packet of type TTL timer expired in transit. So both ASA3, if it's going to do TTL decrementation, and router 3 is going to do the same thing, ICMP TTL expired in transit. So that's how I discover ASA3 and router 3 in the transit path. And then the last device, which is router 4, because router 4 does not have to route the packet and decrement the TTL to 0 to drop it, router 4 is going to send back to the source a ICMP. So 4 is going to send back to the source an ICMP port unreachable, because 4 received the packet destined to itself, a UDP packet, on a port which it doesn't provide any services. So that's why it says I don't provide any services on that port number, and that's how the last hop identifies itself in the path. Now if you go on PCB and try to trace route router 3's loopback, for example, let's go on PCB, trace route 5553, trace route. Let's give it a couple of seconds. Of course, let's make sure it's not going to try to resolve. So let's say trace route. We should say -D, not resolve. So trace route, do not resolve addresses to host names. Trace route -D 5553. So between PCB and router 3's loopback, we should see in the path 2 hops. One hop ASA3 and the second hop router 3. If we look in there, none of the packets are working. We see none of ASA3 or router 3 in the transit path. If we say show logging include 5553, it says deny ICMP source inside to outside 5553. So first of all, it doesn't work because ICMP packets are being dropped, and that is because, as I stated, traceroute on Windows systems, it's nothing else but a ping packet to that destination, but with a low TTL value. So that's how Windows does traceroute. Is going to be a ping packet to the destination with a low TTL value. So traceroute doesn't work initially because the inbound ACL drops the traffic. Let's go on the ASA and say show run access list inside N. And that's because between that subnet and the outside networks, we're only allowing TCP traffic. So let's add one more line which says ACL access list inside N permit ICMP traffic from the inside subnet to the loopback of router 3. Clear logging, buffered. And now let's trace again. We're going to see other problems now. Let's go and trace again from PCB, trace route -D 5553. Let's give it a couple of seconds. If we say show logging, again include 5553, we're going to see what the addition problem is now. It says deny ICMP traffic now from the outside, from the loopback of router tree destined to the inside type 0 code 0. So as I stated, traceroute from Windows systems is nothing else but an ICMP echo with low TTL values, echo request. And then router tree has to send back an ICMP echo reply. But the echo reply is being dropped because, as we saw in the logs, because I am no longer inspecting ICMP globally on the SA. I'm inspecting ICMP on the SA only between VLAN 33 and VLAN 90. So let's go on SA and inspect ICMP globally. Let's go on the SA and say show, first of all, kill logging buffered. And then let's say show run policy map. Conf T, let's go policy map, global policy, class inspection default, and let's say inspect ICMP. And now let's go again on PCB, CLS, and let's trace again to 5553. And as you can see, we see only one hop, which is router tree. We don't see the ASA in the transit path, which clearly the ASA is in the transit path. But because the ASA doesn't do TTL decrementation of packets, that's why I don't see ASA in the transit path, and that's by design. So ASA doesn't decrement TTL packets by default for traffic transiting to the ASA. So if I want to see the ASA in the traceroute path between PCB and router tree, I gotta configure the ASA to perform TTL packet decrementation. If I want the ASA to perform that for all traffic, or depending on for which traffic do I want the ASA to perform that. So configuration wise is going to be the same three steps. One, match on traffic, for which I want to do the TTL documentation. Match on traffic via ACL. For all traffic you want to do TTL documentation, or for specific traffic. Second, configure class map of type layer 3.4, and of course reference the ACL in the class map. And third option, configure policy, configure firewall action, which means TTL decrementation, configure firewall action, which means TTL decrementation, by referencing that class map which I have configured and configuring the firewall action within the policy map. Let's say I want to do TTL decrementation for all traffic passing through the ASA, or actually let's do it only for 5553. So let's say access list TTL decrement, ACL TTL decrement. I want to decrement the TTL, I want the ASA to decrement the TTL only for traffic flowing between that inside subnet to the loopback of router tree, let's say. Then class map, CMAP, TTL decrement, and we say match access list, this ACL, exit, and then show run policy map. I'm gonna still make use of the global policy map. I'm gonna reference my configure class map, class CMAP TTL decrement, and I'm saying for that traffic set connection decrement TTL. If we say show service policy, we should see that for the traffic matched by that class map, I am going to decrement the TTL. So now if I trace route again to the loopback of router tree, I should also see ASA in the transit path. And there we go, now I see two hops. The first hop being ASA3, the IP address of 10.10.33.1, that's my default gateway ASA3, and a second hop being the loopback of router tree. But if I trace route from PCB to the IP address of router 3 on this interface, which is 136.1.38.3, for this traffic, my TTL documentation policy does not apply, which means if I trace route to that destination, I should likewise again only see router 3 in the transit path and not ASA 3. Let's confirm that. Trace route minus D, and let's say 136.1.38.3. Well, now of course I have the problem that ICMP, well, ICMP should be inspected. Should work. 136.1.38.3. Let's see why this doesn't work. Show logging. Include 136.1.38.3. Well, because of the inside correct show run access list, the echo request is not allowed to go out. So let's go on that inside interface ACL and allow ICMP from that subnet where PCB is connected also to host 136.1.38.3. Now let's trace again. CLS. Let's trace again to router 3. And as expected, we see now only router 3 in the transit path, because for traffic source from PCB destined to 136.1.38.3, DSA is not configured to do TTL decrementation, and that's why I don't see ASA in the transit path. I see only router 3. Of course, if you go and you say show service policy, because I matched on my policy with the trace route towards the loopback of router 3, there's no session counters, but I know that for traffic in that policy, matching that class map, I'm going to do TTL documentation.